So in this video, I'll discuss the different phases and states and composition of matter as a result of their intermolecular forces of attraction. So let's have some definition of terms. So matter is anything that has mass and volume. So that's the macroscopic definition of matter. Basta meron siyang mass and volume, we can consider it as matter. Yung microscopic sense naman, ibig sabihin nun, if it is made up of atoms, we can consider that as matter. Atoms themselves can be considered as matter. Actually, atoms are the building blocks of matter. Okay? So matter can exist in various phases and states. So a component or a species or a substance is a particular molecule or ion in the system. So you can count the number of components or species or substance in the system by counting the types or the number of types of molecules or ion that exist in the system. Okay? So a phase is a region of uniform composition and properties. So you can have more than one component or species or substance in a specific phase, basta dapat yung composition and properties ng phase na yon ay uniform throughout the region. Okay? Kapag magkaiba na yung kanilang composition and properties, magkaibang phases na yun. So a state is a manifestation or a description of a phase. So you can have a solid phase, ibig sabihin dinescribe mo na yung phase. Okay? The state is solid, okay? And the phase is solid. So ang mangyayari niyan, you are describing the phase in terms of its state. Okay? So you can also have a liquid phase or a gaseous phase. So dinidescribe mo dito yung state ng ating phase. Okay? That is the manifestation or description of a phase. So we can have condensed phases. So condensed phases are phases that are closely held by their IMFA. So ang example natin doon ay yung solids and liquids. So governed sila ng kanilang intermolecular forces of attraction. Kaya sila closely held. Okay? Yung fluids naman, they are phases or states that are capable of flow. So nagfo-flow sila. Kakaroon sila ng transport of material from one region to another spontaneously or driven by gravity. Okay? So ang examples nun ay liquids or gases. So yung solids hindi sila capable of flow because of their IMFA. So sobrang strong ng kanilang IMFA na maintain nila yung shape nila. Okay? So these are the molecular representations of the physical states. So yung gases, they are fluids, and the kinetic energy of the system is dominant. So yung sa isang atom, yung kinetic energy niya yung mas nagdo-dominate kaysa doon sa IMFA between the particles. So nakaka-move freely throughout the system yung inyong gases. Liquids are also fluids, but the IMFA is dominant. So fluids din sila like gases, pero na-maintain nila yung kanilang density. Yung gases, hindi nila na-maintain yung density nila kasi sensitive sila sa changes in temperature. Again, governed sila ng kinetic energy, yung gases. Yung liquids, governed sila ng IMFA, pero not that very governed na tulad na sila ng solids. Okay? So nagpo-flow pa rin sila, pero closely held pa rin sila ng kanilang IMFA. Solids, hindi sila fluid kasi meron silang specific shapes. Okay? Tapos, they are governed by IMFA or strong ionic bonding in cases of the ionic solids. Tapos, meron silang covalent network solids din, etc. So, matataas ang degree ng IMFA dito or bonding. Kaya, meron silang sariling shape. Hindi sila nag-flow. Okay? So, the density is constant like those of the liquids. Okay? So, ganun din yung sa liquids. Na-maintain nila yung kanilang density. Okay? At least for a certain range of temperatures. Okay? So a system may have one or more components or phases. Okay? So itong system, ito yung ating region of interest or study. Dito natin inaaral yung process at dito tayo kumukuha ng mga parameters ng ating process doon sa system. Okay? If it is a pure substance, ibig sabihin yung system natin, isa lang ang kanyang component. So isa lang yung type ng compound or molecule or ion na nandun sa inyong system. Okay? Kapag mixture naman, it is a multi-component system. Ibig sabihin, two or more components yung nag-exist dun sa ating system. Okay? We can classify a mixture based on the number of phases formed doon sa system. So, homogeneous mixture, ibig sabihin, single-phase mixture lang siya. Kahit more than one component yung nandun sa system, isa lang yung na-form niyang phase. You can also call that a solution. Okay? So, sa solution, we have a solvent and a solute. So yung solvent, that's the medium in the solution. Actually, siya yung nagdidictate ng ating resulting phase. If your solvent is a liquid, most probably yung inyong phase ay liquid. Okay? Kapag solute naman, it is the dispersed component in the solution. So siya yung dinidissolve kumbaga ng ating solvent. Okay? Sa solubility naman, okay? Solubility is the maximum amount of solute that can be dissolved in a solvent at constant temperature. So kung meron kang solute, yung maximum amount ng solute na pwede mong mailagay sa solvent while maintaining the number of phases, dapat isa lang yung phase, yun yung kanyang solubility. Okay? So kapag ka yung solubility ay mas mataas kaysa dun sa actual number of solutes dissolved, ibig sabihin the solute amount is below its solubility, ang tawag doon ay unsaturated solution. So mas konti yung inyong solute component kaysa dun sa kanyang supposed solubility. So kapag saturated naman, the solute amount is equal to its solubility. So na-reach na niya yung maximum amount doon sa system nyo. Kapag supersaturated, the solute amount is beyond its solubility but it is still a solution. Ibig sabihin, isa pa rin yung phase na na-form. So may special ways kung paano mag-prepare ng mga supersaturated solution. Okay? Kapag ka heterogeneous mixture naman, meron tayong na-form na mas maraming phase. So more than one phase yung na-form dun sa system kapag hinalo mo yung mga components. Okay? Here we have some examples. So for number 1, consider a mixture of 0.1 gram sucrose and 100 milliliters of water, this is liquid, at 25 degrees Celsius. So the system consists of two components. So meron tayong sucrose and water. So therefore, it is a mixture. So the system has only one phase. So naghahalo yung ating sucrose at water at nag-form sila ng isang phase lang. So therefore, it is a homogeneous mixture or we can also call that a solution. So yung solvent natin ay yung water, yung solute natin ay yung sucrose. Okay? So the phase is liquid because water is a liquid. So yung ating solvent yung nagdidictate ng phase ng ating system. So therefore, the resulting phase is a liquid. Okay? So the state is described. So therefore, okay, yung ating sucrose solution, yung sucrose plus water natin ay isang homogeneous mixture kasi isa lang ang phase niya and the resulting phase is liquid, okay, in terms of the state. So for the next one, let's consider 10 ml of kerosene and 10 ml of water. So kerosene and water have different IMFA. Hindi sila compatible ng IMFA, so hindi sila nagmi-mix. Kasi yung kerosene natin is mostly LDF only and wala siyang hydrogen bonding participants. Yung water ay puro hydrogen bonding. Okay? So mataas ang degree ng hydrogen bonding between the water molecules. So the system consists of two components. Meron tayong kerosene and water. So mixture din siya. The system has two phases, so ibig sabihin it is a heterogeneous mixture. Okay? So magkaiba yung kerosene phase tsaka water phase. Kahit pareho silang liquid, magkahiwalay sila. Okay? So the kerosene phase is liquid and the aqueous or the water phase is also liquid. So magkaiba silang layers kumbaga kapag minix mo sila. So therefore the mixture is still heterogeneous and both phases are liquids in terms of the state. Okay? So now let's discuss solids. Okay, solids, as I've mentioned earlier, have very strong IMFA and or very strong covalent bonding which maintains its shape and density. Okay? So, describe ko muna yung solids or classify ko muna sila in terms of the order of the components in their structure. So, meron tayong amorphous solids and crystalline solids. So, yung amorphous solids, wala silang recognizable repeating units. Ibig sabihin, wala tayong nakikitang pattern dun sa kanyang structure. Although, the resulting macrostructure is still the same as typical solids. So, wala kayong makikitang repeating units. Okay? Wala siyang pattern in its structure. Yung crystalline solids, however, has a recognizable repeating units called unit cells. So, in this structure, meron tayong nagre-repeat na unit na ganito ang itsura. That is the unit cell of this crystal. Okay? So, it is arranged in an ordered structure called the lattice. So, this is the resulting lattice made up of these repeating units called the unit cells. Okay? So, now let's describe or classify solids in terms of their bonding or IMFA doon sa structure. So, first we have the ionic solids or ionic crystals. So, they have to form crystals kasi they have charges. So, yung mga same charge, hindi dapat sila masyadong magkakalapit. Yung mga opposite charge, dapat yung preferred na magkaka-interact. Okay? So, they are bound by strong ionic bonds due to the attraction between opposite charges. However, they have very limited movement due to the repulsive forces of nearby ions. So, ang nire-refer ko dito ay yung interaction, for example, nito with other cations, okay, or positively charged ions. So, dapat magkakalayo sila kasi pag naglapit sila, mag-breakdown yung ating ionic structure. So, they are hard but brittle and they have very high melting point due to the strong ionic interaction and they are usually transparent or translucent crystals. So, their electrical conductivity is absent or almost absent in the solid state pero present sa molten state. Okay? So for the next type of solid, we have the metallic solids. Okay? So these solids are bound by strong metallic bonds. Okay? But the movement is limited due to the strong interaction. So yung mga overlapping na orbitals tsaka yung mga delocalized electrons, yan yung naglilimit ng movement dun sa mga particles ng inyong metal. Kaya medyo limited pa rin yung vibrations or yung movement ng inyong mga particles inside the structure. So these metals are soft but very dense because of the sizes of the metals. Okay? And they are malleable and ductile with high luster kasi mababa yung kanilang ionization energy, therefore they are lustrous. Tapos they are malleable and ductile due to the flexibility of this delocalized electron cloud. So electrical conductors sila both in the solid and the molten state, again because of this delocalized electron cloud all throughout the structure. Okay? So next we have molecular solids. So in this example, we have water. So yung water na to ay in its ice structure na. So solid water na siya. Kasi due to the temperature, okay, mababa na yung temperature nito, mababa na rin yung kinetic energy ng mga molecules. So nag-govern na yung interaction nila through IMFA. So strongly bound na sila ng kanilang hydrogen bonding at this temperature. So therefore, nagpo-form na sila ng crystals. Okay? So these are molecules bound by strong intermolecular forces of attraction, hindi actual chemical bonding. Okay? The temperature is low enough to reduce the kinetic energy of the individual molecules, which makes them dominated or governed by IMFA. So, makikita natin dito sa structure na nagpo-form na sila ng crystal kasi mababa na yung kinetic energy nila at nag-govern na sila ng kanilang interactions through hydrogen bonding. Okay? So, they are brittle structures kasi these interactions are still not very strong. Okay? They can easily be broken and sometimes they are forming amorphous structures. So kung ano man yung structure niya before siya nag-freeze, depende dun sa rate of freezing nyo. Okay? Nafo-form siya either ng crystal or amorphous solid. Okay? So they have no significant electrical conductivity in the pure state kasi wala naman tayong moving electrons dito or moving charges. Okay? So finally, we have the covalent network solids. So makikita natin dito sa example, this is the diamond structure. So lahat ng carbons yan ay bound through sp3, sp3, overlap ng mga carbons. Okay? So the atoms are bound by the strong covalent bonds. So the movement is limited due to the strong bonds and fixed geometry of each carbon atom in this structure. So this is very hard because of the strong covalent structure or covalent bonding. And this is more durable than ionic crystals kasi wala tayong repulsion or attraction or difference in the charges here. Just pure covalent bonding. So most are not electrically conducting kasi wala naman tayong nakikitang movement of charges, okay, and delocalized electrons except for graphite. So yung graphite meron siyang isang orbital doon na may extra electron na capable of movement around the structure. So graphite is semiconducting. So yung movement ng electrons na yun ay hindi pa rin ganun ka-enough para mag-cause ng conductivity like metals. Pero it's still conducting pero at a lower degree lang. Okay? So now let's proceed to liquids. Okay? So liquids can be classified according to their polarity or yung polarity ng kanilang mga molecules. Okay? So kapag ka non-polar yung ating mga molecules, we consider them as non-polar solvents. So solvents na yung ating term. Okay? Kasi usually yung liquids ginagamit siyang solvents for different purposes. Okay? So these non-polar solvents interact only with LDF or London dispersion force. So meron din tayong polar aprotic solvents. So these are polar molecules pero wala silang H-bond donor groups or yung NH, or FH groups. Okay? So some have strong H-bond acceptor groups, some don't. So for example, yung ating chloroform, it is a polar aprotic solvent pero wala siyang H-bond acceptor. Etong diethyl ether, meron siyang H-bond acceptor pero wala siyang H-bond donor, so polar aprotic siya, as well as tetrahydrofuran and dimethyl sulfoxide. Itong sulfur ay pwedeng H-bond acceptor pero not as strong as yung oxygen, nitrogen, and yung fluorine. Okay? So we also have polar protic solvents. Ito naman yung mga solvents na meron ng H-bond donor groups. Okay? So this donor group makes them capable of hydrogen bonding in their pure state. So meron silang strong interaction. So since meron silang strong hydrogen bonding donors, nakakapag-stabilize din sila ng mga ionic compounds or yung mga ionic solutes. Okay? Kasi mataas ang difference ng electronegativity between, for example, oxygen and hydrogen, nitrogen and hydrogen, and fluorine and hydrogen. So yung mga partially positive and partially negative parts nila nakakapag-stabilize ng mga ions in solution. Okay? So now let's explain the solution process in terms of the three various interactions in the system. So solubility depends on the following interactions. So we have the solvent-solvent interaction or the IMFA between the solvent particles, the solute-solute interaction or the IMFA between the solute particles, and then we have the solute-solvent interaction which is the IMFA between the solute and the solvent particles or molecules. Okay? So a solution forms if the solute-solvent interaction is strong. Since this solute-solvent interaction is stronger than the solute-solute interaction right here, kasi ito makikita natin na dipole-dipole interaction lang siya, pero dito ay hydrogen bonding na, so ibig sabihin nagkakaroon magkakaroon tayo ng solution process or na didissolve yung ating solute sa solvent. So, pwedeng hindi na natin i-consider si solvent-solvent interaction, although may factor to dun sa magiging solubility ng ating solute. Since mas mataas ang solvent-solvent interaction kaysa sa solute-solvent interaction, limited lang yung magiging solubility ng ating solute, which is this one, doon sa solution. Okay? So as long as there is stronger solute-solvent interaction than either of these two interactions, magkakaroon tayo ng solution process or mag-perform tayo ng solution. Nag-iiba lang yung degree niya, depende doon sa solvent-solvent interaction and sometimes doon sa solute-solute interaction. Okay? So, yun yung solution process. Nagko-compare lang tayo ng strength ng IMFA between these three interactions. Okay? We have some notes here on the solution process. So the term solubility is usually applied to solid solutes mixed with liquid solvents. So kapag solid yung solute, yung term natin ay solubility. That's the measurement of the maximum amount of solute that can be dissolved in the solvent at a given temperature. Kapag liquid-liquid mixtures na ang pinag-uusapan, we usually use the term miscibility. So miscible liquids, for example, are liquids that form homogeneous mixture regardless of proportion. So for example, we have liquid A and liquid B. So kahit 50-50 sila or 50% A, 50% B, minix mo at nag-mix sila, kahit 90% A, 10% B, or 10% A, 90% B, regardless of the proportion, pag nami-mix pa rin sila, okay, they are called miscible liquids. Partially miscible liquids are liquids that can only mix at certain proportion. For example, yung A and B again. Kapag hanggang 20% lang yung nami-mix na A sa B, okay, so ibig sabihin that's 20% A, 80% B, tapos beyond the 20% hindi na siya nagmi-mix, okay? That's just the partially miscible liquids. Okay? Ibig sabihin si A and B ay partially miscible liquids. So, for immiscible liquids, kahit anong proportion hindi talaga sila nagmi-mix. So, nagpo-form sila ng more than one phase sa solution kasi hindi sila nagmi-mix. Incompatible ang kanilang IMFA. Okay? So, liquids with stronger IMFA tend to have more surface tension and viscosity. Okay? So, alam naman natin to, na-discuss ko na to dun sa basic concepts of IMFA. And they have less vapor pressure. So some liquids form molecular solids at low temperature. So for example, yung tubig, nagpo-form siya ng ice at 0 degrees Celsius because nagiging dominant na yung IMFA over the kinetic energy of the water molecules. Okay? So the density of the liquid state is usually less than that of the solid state. So it makes sense kasi as your solid state becomes a liquid, as it melts, okay, nakikita natin na nag-expand siya, nagkakaroon siya ng mas dispersed na state. Tapos kapag yung liquid naman ay nag-freeze, okay, nagiging compact yung structure niya. Ang exemption dito ay yung water. So kapag nag-freeze yung water from liquid to solid, bumababa yung kanyang density. Okay? So kapag naman nag-melt yung inyong water, tumataas naman yung density niya. So yung density ng liquid water is greater than the density of ice. Okay? So here we have an exercise. Okay? So what happens to the boiling point and vapor pressure of the compound in column A if the compound in column B is added? Okay? So for example, we have number 1, what happens when you add C8H18 to C7H16? Okay? So sinasabi dito sa sagot na we have an increase in the boiling point and we have a decrease in the vapor pressure. So bakit kaya? Mas mataas yung LDF or IMFA ng ating column B compound kaysa sa column A compound. So kapag minix mo si B sa A, mag-increase yung boiling point ng mixture at magde-decrease yung kanyang vapor pressure. Okay? So try natin sa number 2. What happens when you add water sa acetone? Okay? So yung water meron siyang H-bond donor and H-bond acceptor. Tapos yung acetone natin ay may H-bond acceptor lang. So, kapag nag-add ka ng water, nagkakaroon sila ng hydrogen bonding kasi pwede na mag-accept ng hydrogen bonding yung inyong acetone. So, therefore, yung inyong vapor pressure ay mag-decrease. Okay? Tapos, increase si boiling point. Okay? So, for number 3, what happens when we add this amine, secondary amine sa primary amine? So, mas konti yung H-bond donor ni secondary amine kaysa sa primary amine. So, bababa yung degree ng IMFA. Although pareho lang sila ng carbons. 1, 2, 3, 1, 2, 3. So, mas konti yung kanyang H-bond donor or yung H-bond participants overall kasi this is 1, 2. Ito ay 2, 3. So, 3 yung H-bond participants no nasa column A, 2 lang yung nasa column B. So, mangyayari dito, mag-i-increase yung ating vapor pressure at magde-decrease yung ating boiling point. Okay? So, for number 4, what happens when you add 5-membered cyclic ring? Okay, so 1, 2, 3, 4, 5. This is cyclopentane. Sa 1, 2, 3, 4, 5. This is N-pentane. So, alam natin from our previous discussion na mas mataas yung IMFA ng rings kaysa sa straight chain hydrocarbons. So, ibig sabihin, mas mataas yung IMFA ni B kaysa sa A. So, the vapor pressure will decrease. And the boiling point will increase. Okay? So finally, for number 5, we have this compounds in column A and column B. So may isang branch yung ating column B compound at may isang branch din yung ating column A compound. So pareho sila ng degree of branching. Okay? Pero yung compound sa column B ay ring, yung compound sa column A ay chain. So therefore, decrease pa din in the vapor pressure and increase pa din sa boiling point. Okay? So this is my discussion on the solid and the liquid state. Okay? Continuation ng IMFA. So sa susunod na discussion, I'll discuss the concept of gases and the kinetic molecular theory. So see you next video.